Okay, new topic. In this particular section, we are going to be using derivatives still, but now to find absolute minimum and maximum values. Now, up until this particular lecture and the previous lectures, we've been finding the relative mins and maxes, which means we've been only looking at a small portion of the domain, not the entire domain. In this particular section, we're going to be talking about the entire domain. Okay? In this lecture, we're going to be talking about the entire domain and finding the absolute min and max. Cool? Okay, but before we get there, let's look at a definition. It says, suppose that f is a function with the domain of I. F of c, do you remember what c represented if you looked at my previous lecture videos on first and second derivatives to classify mins and maxes? Yeah, c was that critical value, right? Okay, just a quick refresher. So f of c, which means the y value at c, right? Plug in c, this is the y value. So the y value at c is an absolute minimum if the y value at c is less than all the other y values for every x and I being that interval, okay, that domain. The second part of this definition says f of c, which is the y value when you plug in c, is an absolute maximum if that y value at c is greater than or equal to all the other y values for all of those x's into I. Cool? Okay, awesome. We good so far? The next item I'd like to go over is a theorem. And this says a continuous function f defined over a closed interval, which means brackets, a, b, must, this is key, it must have an absolute maximum and minimum on this closed interval. So that's cool. That theorem's really nice. If I'm dealing with a closed interval and I have a continuous function, I must have that absolute min or max. Perfect. Now, I've got one more theorem before we get into a couple of examples, so stay tuned. All right, let's look at this theorem. Theorem 8 is known as the maximum minimum principle number 1, which implies there's a principle number 2, but we'll get there, so hang in there. So, it says, suppose f is a continuous function defined over a closed interval, a,b. So that's important. This particular theorem is dealing with a continuous function and it's over a closed interval. To find the absolute minimum and maximum values over that closed interval AB, first, find the derivative. Second, determine the critical values and make certain those critical values are in the closed interval AB. Because here's the deal, if you find critical values and they're not in this closed interval, you can't use them. All right, plain and simple, can't use them. 3, list the critical values that you just found in step 2 as well as the endpoints that they gave you. And the endpoints would be A and B. Step 4, find f of x. Find the y values for each of those values in step 3. So for the critical value and the endpoints, go find the y's. That's what step 4 says. And now, when you do these 4 steps, which are quite simple, the largest of these f of x's, the largest of those y's, is the absolute maximum of f in that closed interval, and the smallest is the absolute minimum. Cool? Okay, so we are going to do a couple of examples based upon this theorem, and you know it's based upon this theorem because we're going to be dealing with a closed interval. So stay tuned. All right, as promised, we have a couple of examples. The directions say to find the absolute min and max. So let's look at the first one. They've given me a function and they've given me a closed interval. And because they gave me a closed interval, I can use that theorem 8 that we just spoke about. So, first things first, we're going to find the first derivative. Why? Because I need to find the critical values. Remember, first derivative implies go find those critical values. So, find the first derivative. What do we have? 1 minus 2x. Agreed? Find the critical value, which means set it equal to 0 and solve for x, right? So let's move things over. Good? Okay. Now, is this critical value in that closed interval? Yes. Yay! That means we can use it. Because if it wasn't in that closed interval, we can't use it. Okay, and now I am going to use my endpoints and my critical values to find the y's that go with them. All right? Because that third step says, hey, list the endpoints out along with the critical value. So I'm just listing them in numerical order. Now, how do you find the y's that go with these? Plug it into the original function. Now, I'm not going to insult your intelligence. You all can plug these three numbers into this function as well as I can. So, f of 0 was, I got just 5. F of 1/2, what did I get when I plugged that in? I got 21 over 4. And then f of 2, when I plugged that in, I got 3. Good? And now I can actually determine what the absolute max and min are based upon the y values. So, which is the smallest y value? The 3. That means my absolute minimum is y equals 3, and it occurs at x equal 2. Good? What about the absolute max? Yeah, 21 over 4. So, the absolute max is y equals 21 over 4, and it occurs at x equals 1/2. Cool? All right, let's look at this other example. Same directions, determine the absolute min and max. They've given me a closed interval, and because they gave me a closed interval, I can use that theorem 8. Got it? Okay, so first things first, what are we going to do? Good, find the first derivative. Why? I need a critical value. Excellent, good job. Okay, so first derivative, 3x squared minus 2x minus 1. To find the critical, we set it equal to 0. And we solve, and in this case, it looks like we are going to be factoring, right? Or you can use the quadratic formula, whatever floats your boat. And it looks like I have two criticals. X is equal to negative 1/3, and x is equal to a positive 1. Now, before we go any further, the question is, do both of these critical values fall within that closed interval? The negative 1/3 sure does, but does the 1? No, and since the 1 does not fall within this interval, I can't use it. All I can use is that x equaling negative 1/3. With me? Okay, so now I have x is equal to negative 1, x is equal to negative 1/3, and x is equal to 0. I have 3 x's that I can use. Got it? All right. Now again, you have to find the y values, and I'm not going to insult your intelligence because you can plug these numbers into that function as well as I can. For the negative 1, I got a value of 2. For the negative 1/3, and I know some of you using your calculators, try to do it by hand, but if you have to use your calculator, okay. I got 86 over 27. That's a fun little number, isn't it? And then for the 0, I got 3. Agreed? Okay. So, absolute minimum. I'm going to abbreviate absolute. What would my absolute minimum be? Yeah, the absolute minimum would be 2, right? So the absolute minimum is y equals 2, and it occurs at x equaling -1. So what about that absolute max? Yeah, 86 over 27. Okay, get your calculators out. Yeah, that's a little over 3, isn't it? So since this is a little over 3, that means that the absolute max is the 86 over 27, and it occurs at x equaling a -1/3. Good? Okay, now I'm going to be back with another theorem, because you know as well as I do, we don't always get closed intervals. So if we don't have a closed interval, if we have an open interval, how do we find absolute mins and maxes? Stay tuned for that. Okay, so let's look at this next theorem. It's talking about the max-min principle 2. Suppose f is a continuous function such that the first derivative exists for every x in an interval I. Now I'm going to stop a second. Do you notice it said nothing about interval I? It didn't say it was open, it didn't say it was closed, it just said we have an interval I. Since it didn't say it was closed, you can't assume it, which means you have to assume an open interval. Just FYI. And so I've got this continuous function, and the first derivative exists for every x in that interval, and there is exactly one critical value c in I, for which f prime of c equals 0, which we're used to. Then f of c, that's the y value at c, correct, is the absolute maximum value over I if the second derivative is less than 0. Now like, wait a minute, I don't remember what the second derivative tells me. That's right, some of you said it. The second derivative tells me concavity. So if your second derivative is less than 0, which way is the graph concaving? It's concaving down, which means I have a max, right? Second part here says f of c, so that's the y value at c, is the absolute minimum over I if that second derivative is greater than 0. Remember, second derivative means concavity, so if the second derivative is greater than 0, it's concaving up, which means I have a minimum, right? Okay, stay tuned. Got a couple examples for. Okay, so look at the directions. They're asking us to find the absolute min and maximum values, and they say if no interval is given, use -infinity to +infinity. So number one, they gave us a function, but they didn't give us an interval, did they? So we have to assume -infinity to +infinity. But regardless, I still need to find critical values, don't I? Okay, so to find the critical value, that's right, take the first derivative. So what is that, 30 minus x? Set it equal to 0. Whoops, that's a 2x, I'm so sorry. 30 minus 2x. Set it equal to 0. Solve for x, and we get x is equal to 15, correct? Good. I still have to find the y value. That doesn't change. So f of 15, you plug it in, what'd you get? I got 225. Good? Okay. Now, here's the deal. Theorems 8 and 9 both tell me find the critical value, find the y's that go with those critical values, which we did. Now we change a little bit. Because this is not a closed interval, I can't do what I did in the last couple of problems. Because it's not a closed interval, this is all I have to work with, is that 1x. And by the way, Theorem 9 says there's exactly one critical value. So here's the exact one critical value I'm going to be using in this interval. And now I need to determine if this is going to be considered, 225 is going to be considered an absolute minimum, or an absolute maximum. And how do I do that? Good, I've got to find the second derivative. So, to determine, right, absolute min or max, you've got to find the second derivative. So, second derivative would be, here's my first derivative, right? Second derivative would be -2, wouldn't it? And technically, I'm supposed to like be able to plug the x in, but even if I plug the x in, I just get -2, don't I? So -2 is clearly less than 0. It's a negative number. So remember, that means since my second derivative is less than 0, this is concaving which direction? This concaves down, which means we have an absolute max, good, at 225, and it occurs, I should say the absolute max is 225 and occurs at 15. Good? Okay, let's look at number 2. Now, number 2, I forgot something on number 2. Number 2 actually gives me this interval. Now question, is it a closed interval? No, it's not. So that should give us a clue right there. Regardless, I still need to find my critical values, which means I still need to find the first derivative. Now, again, I don't like it when they do this when I have a fraction and a non-fraction. I am going to combine these into a single fraction because it makes life just that much simpler to deal with. Like, how'd you do that so fast? Remember common denominator? I need to multiply top and bottom here by an x. Good? Yeah, I'm assuming you remember how to find the common denominator and add fractions. So, brush up on it. Okay. Find that first derivative. I have a quotient. Okay, so that's going to be 4x, right? Derivative of the numerator times the denominator minus the numerator times the derivative of the denominator all over the denominator squared. Simplifying, I have 4x squared minus 2x squared minus 72 over x squared. Simplify it even further, I have 2x squared minus 72 over x squared. Good? Okay, but I still need to find the critical value, which means what are we going to do? Yeah, we are going to set this equal to 0 and solve. And when we do that, first thing we do is multiply both sides by x squared, which means I have 0 equals 2x squared minus 72, because that denominator cancels. Do your algebra. We have 72 equals 2x squared equals 36, x equals a -6, and x equals a +6. Agreed? Good. Now, something to consider. 2 things to look at, actually. Since this is an open interval, Theorem 9, which is what we're going to be using, says there's exactly 1 critical value to use. I can't have 2. I can only have 1. Gratefully, let me back up. If they did not give me this interval, I would have been using negative infinity to positive infinity, and I would have had 2 critical values, which leads me up a creek because I couldn't even use Theorem 9 to find an absolute min or max because I didn't have 1, I had 2 critical values. Therefore, this restriction was put here so that we could eliminate one of the critical values. -6 doesn't fall between 0 and infinity, so I'm excluding it. I'm kicking it out. And now I only have one critical value in the open interval that I am now working with. Does that make sense? Okay. How are we doing? So far, so good? All right, so I have my one critical value, that's x equals 6, and now I've got to find, good, the y that goes with it. Excellent, which is why I'm getting some board space for us. So my critical value is x equals 6. To find f of 6, you have to plug it in, don't you? All right, let's see, what did I get when I plugged it in? I got 24. Hopefully you agree. All right, and now we have to determine if this is going to be an absolute min or max. By doing what? Yeah, I got to find that second derivative. Wasn't this a fun little problem? So, to determine the absolute min or max, my first derivative is right here. I need the second derivative. Again, we have got a quotient rule, so here we go. See if you follow along. Derivative of the numerator times the denominator minus the numerator times the derivative of the denominator all over that denominator squared. Time to simplify it. What do we get there? 4x cubed minus 144x, right? Looks like my x cubes are going to cancel. Thank goodness for that. Because if they didn't cancel, we'd have just a lot of powers to deal with. So, second derivative is 144x over x to the fourth, which can still be simplified to 144 over x cubed. Agreed? Lovely. And now, are we done? No, we have to determine if it's greater than or less than 0. Okay, how am I going to determine if that's less than or greater than 0 when there's an x in there? Yeah, I know x. Good job. All right, so the second derivative evaluated at 6. You work it out. I already got my answer. I have 144 over 216, which is definitely greater than 0, which means this thing concaves up, which means 24 is an absolute minimum. Absolute min is 24, and it occurs at 6. Wonderful. Good? Does that make sense? Yeah. This problem was a little more involved than number 1. Why? Because of the function it gave me and me having to find the derivative twice, using the quotient rule twice, right? Anyway, I have a couple of stories for us. So we just looked at a story. Let's kind of go over it again. It says an employee's monthly productivity, and they call it M, in number of units produced, is found to be a function of the number of T years of service. For a certain product, a productivity function is given. And notice they've given me an interval to work off of, right? T is the number of years of service. So the number of years of service is between 0 and 40 inclusive. So technically it's a closed interval, isn't it? All right. Find the maximum productivity in the year in which it is achieved. Okay. So, the fact that it says find the maximum and they've given me a closed interval tells me to find the absolute maximum. They said find the maximum over a closed interval, basically. Find absolute maximum is what they're alluding to, though. They didn't say the word absolute. So here we go. What do we do first? Find the derivative. So the derivative is negative 4t plus 96. Critical value, how? Set it equal to 0. And when you solve this, you end up with t equaling 24. Excellent. So I have 24 years of service, right? Aha. Then do what? Yes. Find the y value, so to speak, that goes with the 24, right? So now I've got to find the productivity at 24 years. So you plug it in, because I've already plugged it in. I got 1,332 units, because it was also in units. Agreed? Okay, now here's the thing. I'm hoping that's the absolute maximum. I still have to determine if it is the absolute maximum, right? So how do I do that? Yeah, I have to take these other x's. So I have to take x equals 0, x equals the 24, and x equals the 40. And I've got to find the y that goes with each. And instead of the y, I am going to call it, oh, and they're not even x's. Yeah, I heard ya. Though some of you did what I did. We called them x's. But my variable is t, right? So we have to figure out m of 0, which is 180, m of 24, which we figured out was 1,332, and m of 40, which I got 820. So, closed interval, 24 fell within the closed interval, gratefully. I used all three of these, and now my absolute max. Very easy to identify. The absolute max is 1,332 units at 24 years of service. Cool? Cool. Got one more story. So let's look at the last story again. I know you just read it, but let's look at it again. It says for dosage of X cubic centimeters of a certain drug, the resulting blood pressure, which is given by B, is approximated by this function. So B is the blood pressure, X is a dosage in cc's, right? Cubic centimeters. They would like us to find the maximum blood pressure and the dosage at which it occurs. Okay. Now, they gave me an interval here, and it's a closed interval, right? And they want the maximum, which means, yeah, we get to use Theorem 8. Theorem 9 is the open interval. And you don't really have to remember the theorems by numbers even. Understand their principles. Because regardless of which theorem you're going to use, you're going to have to find what first. Yeah, you're going to have to find the first derivative. So let's find the first derivative. And I get, and hopefully you're agreeing, right? And then to find critical value, you've got to set it equal to 0. And yes, 760 does factor out of both of them. I've already done this work. Hurrah! And we set each of these factors equal to 0. And when we do that, we end up with these two critical values. Now notice, 0 is already one of the endpoints, correct? 1/6 is approximately 0.17. because it did say in the directions to give them 2 decimal places. So it does fall within here, so we're good. Now, find the y's. And I'm going to find, since I have a closed interval, I'm going to find 3 y values. And yes, I'm going to leave this as 1/6 because it'll give me a more exact answer. And then I'll change the 1/6 into a decimal at the end if that turns out to be the answer. All right? So, the blood pressure at 0, well, that's 0. And at 1/6, what'd you get? Okay, I got the same thing. I got 3.52. And at the 0.25, yeah, I got 0 also. That was kind of weird, but that's what it gave me. So they wanted an absolute, or they wanted a max. They didn't say absolute max, but you know it's the absolute max because I'm dealing with a closed interval. So what's my absolute max? Yeah, the absolute maximum blood pressure is 3.52. It's an interesting way they're measuring it. I'm not familiar with that, but that's okay. And it occurs at 0.17 cc's, doesn't it? Because that's the dosage. Agreed? Okay, hopefully you found this particular lecture simpler than maybe a couple other ones that you've already looked at. You have fun with this stuff, and I'll catch you on the flip